this is Mr. Reddick again. We're looking at the 1.8 homework now. And the 1.8 homework is about writing explicit and recursive equations. But you already know this. We've been doing this a while. So let's take a look at this. This one says they're all geometric, which that's a good thing. That means that you know this is going to look, it's going to have a common ratio for each one of these, and these are going to be pretty easy. Okay, now these don't say, but it does ask for a recursive and an explicit rule. Now it depends on whether it's arithmetic or geometric as to what that's going to look like. Recursive, you're always going to be adding the same thing for an arithmetic. For a geometric, it's going to be multiplying by the same thing. So if I take a look at this sequence, it looks like it's going down by the same number every time. So this one's going to be arithmetic, isn't it? I'm going to put A for arithmetic. This one, on the other hand, it's not going up by adding the same number. It's going up by multiplying the same number. So this one is going to be geometric. And so your recursive rule for the geometric is going to involve a multiplying, and your recursive rule for the arithmetic is going to involve an adding or subtracting. And then the explicit rule, remember, it looks like this, that you take the common difference and you multiply it times n minus 1 if it starts with 1. This one does start with 1, first term. And then you add to it whatever the first term is. So that will be easy enough. You just got to figure out what the common difference is, and you got this one, okay? And this one, likewise, the common ratio is what you're going to be multiplying it by for the recursive rule. So this is f of n minus 1. I can't fit the f of n in here, so it would go before it, f of n equals f of n minus 1 times r. Hopefully you can write it neater than that. The explicit, remember, you start with that first term, whatever the first term is, which in this case is 3. Then you multiply it, and we'll put it in parentheses, by whatever r is. You can figure out what r is here, to the n minus 1, and you're done. Now this one actually is really simple, can be written a lot easier than this, but I'll let you figure that out. More importantly, and this is what I wanted to give the reminder on, if we're going to write an equation in y equals mx plus b form, that's slope-intercept. With m, which is the slope, and b is the y-intercept. So you need to know what both of those are. Well, m in this case, we're going to start at a convenient point, which in this case would be right there, and we're going to go up 1, 2, 3. So this is a 3. Looks like it's going to be a positive slope. And then we go to the right, 1. So the slope, which we use as the letter m, is equal to 3 over 1. Now the y-intercept is the spot where it crosses the y-axis, which in this case is 2. So we say b, which is the y-intercept, is equal to 2. So the m is 3 and b is 2. And so the equation, which is y equals, that's an equals, not a less greater than symbol, equals m times x plus b. Well, m is 3, so it's y equals 3x plus 2. Now, I don't think you can do the rest of this on your own. It's pretty obvious what the b is for this one. Now, some of you are having some trouble with the slope on this. Remember that you, from whatever point you start from, you want to either go up or down. In this case, it's obviously down. You want to go to a convenient location that's going to be right across from the other point. So you should be able to get the slope now. What goes here, I wonder? And then that tells you what goes there. then this goes there, and you can write the equation. Yep, got it?